Welcome back to Kennel Corner Racing. What we're going to do right now is I'm going to explain Squish, why we set it, and how we do it. This is a picture, basically, it's a rough picture, but here's the cases, here's the bore for your main bearing, connecting rod, piston, and cylinder head, cylinder. The reason we do this is because when the Japanese make this, and no fault to them, I mean, they're making millions and millions of parts. Some stuff is going to be different as they send it through the lines. What these guys do is they mix and match parts to set these engines up to where they're going to run. I'm going to explain some of the compounding tolerances is what I call them. This would be the bore in the cases for your main bearings. And this is where your cylinder sits. This can be off, plus or minus, they have a tolerance. The next thing is the distance on the crankshaft from the center line of the main bearings to where the big end of the crank pin goes. That's going to be different, a little bit here and there. The other thing is the connecting rod length. From the center of the connecting rod to the top of it, I've seen these things vary as much as 20 thousandths short and 10 thousandths long, and I'm sure it's a lot worse than that. The other thing is the pinhole in your piston. To the top of your piston, there's going to be a tolerance in there. Another tolerance is the length of the cylinder. That's going to be different. And another one right here is where they actually cut in your squish band. Squish is extremely important to the proper operation of a two-stroke motorcycle. You get a good squish band in there, you're going to get a lot of power, you're going to get a lot of cooling. So I'll show you how I check that, and then I'll show you how I adjust it. Alright, what I got here is nothing fancy. This is 1/8 flux core solder. That's all it is. This is what I'm going to use to check it. I'm going to actually slide this part of it inside of the cylinder, one on each side to side, not front to back, side to side. I'm going to slide this in, and then we're going to turn this nut right here on the crankshaft counterclockwise, and that's going to bring the piston up, and it's going to squish this solder, and then I'm going to come off and I'm going to take a dimension on it. Alright, we went ahead and did the compression on the flux core solder, and what I have is I've got an impression of what it looks like inside of the combustion chamber. Again, this is not my design motor, this is just something that I'm putting together for a favor for somebody, but there's dimensions in here, and what I'm going to do next is I'm going to check this and see where I'm at. Okay, what I'm going to do now is I'm going to measure my solder. Right here I got 46 thousandths. The weird thing is, as I bring it up, I got 73. Again, this is not a motor I designed or built or anything, I'm just putting it together. But this is not, I run 11 degrees, this shouldn't change that much, but coming back on the lower side of it at 47, I got a decent squish on this side of the motor. My other one, at 43. Come back here to 68. And again, I got to stress, I didn't design this motor, but this will work. So I've checked my squish, and again, compounding tolerances. We're checking this. We change crankshaft, we change a piston, we change a whole bunch of stuff. So we're just making sure we're in the ballpark, and I'm going to run this just like it sits.